Okay, welcome back. We are going to do part two of this thing here, where we're really talking about from the Pitt packet, Unit 3, Activity 1, the lab assignment there. So we already did one in a previous video, and in this video, we're going to do problem number 2, along with a little bit of extra, what's called a quadratic regression. But we'll get there once we're done and show you how to do a lot of this and continue to do a lot of this on your calculator so you have practice for future quizzes and midterms. So here's the problem. You got a diver who's jumping upward from a platform 40 meters above the water, and the platform's 40 meters, and you have an initial speed of 10 meters per second. So you have all these numbers floating around. But really, what's most important is that you have a function, h, which I'm going to call f of t, and I'm going to kind of draw this in here as I'm talking to you, where your function is modeled by minus or negative 5 of t squared um, plus 10t. Now notice in this case we can call this t or x if we want, and this is just going to be represented by time, and plus 40 over here on the right side. So you don't want to forget that 40. That's a big deal. And I'm going to go ahead and again, I know that the highest degree is 2, so I have a quadratic function. I've already done the problem, so I'm going to kind of just put in a temporary graph here, which is okay for you to do on your midterms as well, as long as you're able to label the points. Now, notice I haven't defined the variables yet, but this is going to be time, or my x, and this is going to be height, right, or my y. So this is time, and that's height. And I also have a graph here that's going to have a y value of, before we even get started or read any problems, let's see if we can do that real quick. As in previous examples, if I plug in for a y-intercept, I know that the x value or the input value is 0. So this is going to be 0. This is going to be 0. 10 times 0 is 0. Negative 5 times 0 squared 0. And all I would be left with is 40. So this value here, before we do anything, is 0 comma 40. And you can fill in your table here as well. Now, I haven't read the problem yet. I'm just getting started. But notice what I have already. I've done some things very subtly, um, and I'll kind of try to mention them to you right now. We've already figured out the y-intercept by messing with these values that I crossed out, just for the y-intercept, because you're usually always going to have to know that. We have plugged it in here, labeled it on a graph here, and at the same time also labeled our variables, which again you'll get points for. Here's y, excuse me, x, which is time, and in this case, this is going to be height. Now notice that's in, let's see, meters. So as long as you label that stuff, it's kind of hard to not know what number you're talking about, as long as you know that x is always before y when you write it as a point. In other words, if I ask you, what does this mean, 0, and this might be part of the problem. I haven't read all of the problem, but this is x and this is y. If I said, what is the meaning, hint, hint, whenever I say hint, hint, I'm going to ask that on the midterm. I'm going to ask you for that value, 0 comma 40, and the numbers might be different and the meaning might be different, but the process to go about explaining it is the same. So for the y-intercept, you know the input is 0. So in this case, at 0 seconds, right, time in seconds, let me make sure it's in seconds. Yeah, the initial height of my diver is 40 meters off the ground, which was also stated just blatantly in the word problem. And at this point, I'm not even looking at the word problem at all. I'm just going to kind of know that x is time, y is height, or you can call it t and h of the rate, or there the book is using f of t, which represents the height during some time. Now, the other things and key factors we've been playing with the whole semester are, what do the x-intercepts mean, right? And this one, like in previous examples, means nothing because it's before, if time 0 starts when the diver starts his dive, this function only applies when he's in free fall, or her when she's diving off the platform. And they do this all the time for like the Red Bull dives. If you have you guys seen that? It's cliff diving, and maybe I'll put a video of the cliff diving just for a little example if you want to see people diving after this video. Maybe attach. Um, somebody in the Red Bull thing. They just fall and fall and fall. They jump off a cliff. It's pretty interesting, actually. So let's get going. All right. So if I know at 0, the diver's at a height of 40, and I've already kind of created an accurate graph of the height, and I've labeled that clearly. We will complete this table. You know what? Let's just complete the table now, again, before I even move forward. And to do that, you could go ahead and plug in 1 into the input. So you could go -5 times 1 squared plus 10 times 1. Don't forget that 40 over here, right? Plus 40. And you could crank that all out. Now, you could do that and then plug in 2, plug in 3, plug in 4, and get out all their corresponding values and put that here, 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 and here. And you're more than welcome to do that. But part of what I'm trying to get you to do when you are messing with these problems is work a little smarter too. Let's go to our calculator for a second. Now, again, I've already pre-put these in, so you won't be moving this fast. But once that's in, here's another feature on your calculator. Then let me go ahead and bonk over because I always forget to let you guys see what I'm looking at. So if you are going ahead and hopefully you're looking at the right thing, the calculator, and here's your y function. All I've done is I've plugged it in, and you could play around with the window and the graph. I'll tell you what, let's mess around. So if you hit zoom, do this with me. And if you need time again, I'm just going to keep moving. But pause the video, plug the function in, and come back here. It hit zoom, and let's look at our function in a standard viewing window. It doesn't look too good. So what you can do, you can zoom out, just like a camera or your iPhone. You can zoom out and hit enter. And please don't just be watching me. Or you can zoom in, mess around with these features so you're comfortable, and messing around on your calculator isn't going to take up significant time when you take this on a midterm. You're going to need your calculator for the midterm and the final when it comes. Now I'm zooming in and out as I'm talking. Let's mess with my window. Remember, I need a diver that's going to be 40 feet to begin with. Probably not going to jump too much higher than 40 feet. So I'm just going to make an educated guess. If my diver is 40 feet, let's just go up to 80. And again, I don't know what I'm doing here. I'm making educated guesses. If I'm going to count all the way up to 80, maybe let your scale be 5. Count by 5s. That's what that means. And for the x value, I don't need to know what's going to happen negative time. A lot of time I'll put that there just so I can kind of frame my graph, so to speak. So I'll leave a little frame on the left. So -4, but my diver, maybe 10 seconds. Diver's only going to be in the air, hopefully a couple seconds, unless you're falling really far. And again, the video I'll attach at the back of this might be interesting too. So we'll see for the Red Bull free diving. But let's say X max only goes to 5 seconds, and we'll count by half seconds. And again, I'm guessing, but let's see what our graph looks like. Not too shabby. So if that's our graph, we now have the ability to, we already know the y-intercept. We can go ahead and find the max and this value if we needed to per other discussions. But something we haven't done yet, and the reason I want to do this on video is let's take a look at the table. So hit second function, table setup, and we're going to set up a table that's going to start, I think your table starts at -1 in the function. And I'm going to write this down too as I'm talking that way. Sorry for taking a while here. It starts at -1. It counts by 0, 1, 2, 3, 4, 5, and so forth, I think is what the table does. But that's what this change in table means. You're going to count by seconds. And your calculator, if it does it automatically, it's automatically going to calculate everything. So we don't need to touch anything else. Let's go over here to the table function and hit second table. And what that's going to do for you, it's going to self-generate your table so you don't have to do any work. Now write those values down somewhere, which I'm doing right now as we're speaking, so I can translate that over to the problem that we're working on. Okay, so now if I go over to my screen sharing and I stop this, and I mess around with my table now on my graph, if you're let's go ahead and transfer those values in here. At minus 1 second, I'm minus 25 feet. So that means I'm back here somewhere. And again, you don't care about this value at all. It doesn't make sense in the context of your problem. It's extraneous. At 0 seconds, you're 40 feet off the ground, or 40 meters. 1 second, I think we had 45. And then I started to come down to 40, to 25, to 0. And after 5 seconds down here, I'm at negative 35. That doesn't matter either, does it? Because I hit the water. I'm not going to continue to go down as fast as, in water as you are when you're in airborne and free falling in air. So the question on the table here for part C is, how does the diver reach a height of 50 meters? Or does they? Do they? Does she? Does he? So does the diver reach a height of 50 meters? And to do that, all we have to do, we can do it a couple ways, but let's find out that vertex from our calculator. So again, you could do the whole, remember this equation of that asymptote, the vertical asymptote, or the line of symmetry. No, I'm sorry, I misspoke. It's a axis of symmetry, minus b over 2a. Now, if I wanted to do that, you could crank all that out. And I'm going to just go ahead and choose to, again, use my calculator, because I know I have a nice graph. So let's get you viewing the calculator portion. And if you're going to do that, what you can do is go ahead and hit second, calculate maximum. Now, if you're going to do this on a test or something like that, just say I calculated it using my calculator. And so left bound, hit enter. Scroll over. Right bound, in other words, the point, the maximum was in between those two values, and then hit enter one more time. And you'll see that at about 1 second, notice when x is almost 1, y is 45. So that's very important because that's as high up as the diver can get, 45 meters off the ground. So coming back to your video here, this point, 1 comma 45 is the maximum height. This is the max height in the table. So here's some big words. This is called solving a problem using multiple representations. And all that really means is we're solving it doing a variety of ways. We've done it on a calculator. We've done it by hand on a graph. We've done it using a table. And really, what I'm asking you to do on the midterm is show that you have mastery, or even on lab assignment, show that you're able to do this in a variety of forms and make sense of what you're doing. So for part C, does the diver reach a height of 50 meters? No. So go ahead and write that in there. No. Max height is 45. Okay, and you could even say at 1 second, max height at 1 second is 45. Now, do you see what I'm saying? Here's an x value, here's a y value, 1 comma 45. All I'm doing is explaining this and communicating it so that I can use it in a sentence and make sense of what's going on. Now for part D, how long does it take the diver to hit the water? They're asking for that x-intercept, aren't they? Where the y value is 0. Now, again, you could do this a variety of ways. You could use this whole function, and you could set 0 equal to minus 5t squared plus 10t plus 40. You could use a quadratic formula. You could factor something out if you could. So like real quick, let's see if I can do it. If I pull a minus 5 out of that, I'd have t squared minus 2t, minus 8, looks like. Does that make sense? And so 0 would equal minus 5, that stays there. Could you FOIL it? Now, you could use your calculator. We've done all sorts of different techniques. But this looks like minus 4 and t plus 2 might work. So what does that mean? Either t minus 4 has to equal 0, because you have to solve for the actual value, which means t equals 4, or t minus 2 or plus 2 equals 0. So that's this value here, when time equals negative 2, but again, you don't care about it, so you throw it out. So how long does it take the diver to hit the water? 4 seconds. And hopefully you could do this on a calculator using that x-intercept, or finding zero, excuse me. You could actually look in your table and it's right there for you. So the answer is right in front of your face. Hopefully things are progressing okay. And let's go ahead and see if we can do the other parts here. So find the values for which your function is 25. Let's say I wanted to know when the diver is 25 feet high off the ground. Let's see if I can erase a couple things here just to clean it up. In other words, when is your diver going to be? Now 40 is there, so I don't know, maybe somewhere in here. When is your diver 25? See what I want? I want that value right there. When is your diver 25, I keep saying feet too, I'm sorry, meters off the ground? And to do that again, let's go to our calculator. And hopefully this is helping. And you could take your function and say y equals. And as I start to move a little faster here, because I'm expecting you to be able to follow this and do it yourselves, if I go ahead and enter that in, that's important to do, graph it, you now have a function that has two intercepts at 25 meters high. Notice the one on the left here that my cursor is circling does not make sense in the context of the problem, but the one over here on the right would. So second, calculate, the intersection. And remember, you want to go over to your intersection that's you're interested in, somewhere close to that. Enter. And at 3 seconds, the diver will be 25 feet meters off the ground. Okay, so if we're doing that and speaking in those terms, we've already done it using a calculator. So you can say at 3 seconds, the diver is 25 meters high. Let's just say that. So that's the kind of explanation I'm going to be looking for, and that's what's going to get you credit on a midterm. All right. So notice I just did that part for E, and you could write 3, 25. But again, using multiple representations, we did it finding the intersects feature on your calculator. We spoke in English here, right, to communicate our answer. We found it on a graph here. And again, check this out. If I go up here, at 3 seconds, my answer was already in that table too. So make sure you know that there's a zillion different ways to do this stuff, or multiple ways to do the same thing. And how you do it most often is going to be up to you. I want you to be well versed in all the options available to you. Okay, let's see what else we have going on. Maybe I'll talk you through this last one. If you're being asked to find values when it's 20, now notice this isn't 20. I can't cheat this time where I could have before. 20 is not no value on my table here. It's right between 25 and 0 as a height. So it's after 3 seconds. I know that, right? Because I'm looking after 3 seconds, I'm 25 feet or meters high, and after 4 seconds, I've hit the water. So I know it's between 3 and 4 seconds, but if they, or when I say they, I mean the people making the problems, myself or some other mathematician, I have a tendency to do that, so I apologize. But if I'm asking you when is it going to be 20 feet high, notice this is the output. I'm giving you the output, and I want the corresponding time. That's what you're being asked for. So most of your questions, even if they're word related, you'll have everything but one thing, and in this case, you want time. Now, if I want that when that's 20 off the ground, 20 meters, you could again, by hand, crank this out and use a quadratic formula. 20 minus 5t squared. What's the rest of that? And see what I'm doing? Plus 10t plus 40. And you could move the 20 over then you'd have 0 equals minus 5t squared plus 10t plus 20. That's a plus. Or you could use your calculator. So again, you could keep going this way, factor it, or quadratic formula. I just don't want to work that hard this time. So if I go over here to my calculator again and just go back, again, if I'm going too fast, just pause the video, rewind it. But instead of 25, we're just going to put 20 here and redo the entire thing, what we did prior when it was 25, except now the height is 20. So here we go again. Second feature, calculate intersection. Slide that thing on over to the intersection you're interested in. And I'll leave you here. The intersection happens at 3.236 seconds. How's that for you? Okay, so you can see the value there for x. It's 3.23 seconds. The height will be 20 meters off the ground. Now, do me a favor. We're going to do one more exercise here, and then I'll let you go. Hopefully you've made it this long. Hopefully all your answers are correct. Please go up here and go ahead and clear out your values. I'm going to show you how to do a regression real quick for the future. So hopefully you're listening. If you know your table on a calculator, and by the table, let's say, and again, I'm changing the problem. We're done with this one. Hopefully all your answers have been completed. But let's just pretend for a second that the table, you don't have a function, you just have some information. And that the table is the only thing you have. So again, I'm changing the whole problem. The video now is going to be on a different calculator technique called finding a regression equation. And a regression equation is a way, if you're not given this function for f of t, the regression equation is a way to come up with it if you're just given values in a table. So if you just know some isolated values, you can actually come up with this formula, because that used to be my question all the time. How do these people get these formulas? So this is kind of the bonus part of this video, to find the formula by using the table. First off, write that table somewhere. I have mine already pre-written. And I'm going to take you on over to my calculator. Go to your calculator. And this is crucial that you know how to do for statistics anyways. So make sure you can do this. And go ahead and hit your stat button. Okay, so your stat button, you're going to get the option to edit in some information. So again, it doesn't matter where you are. You can go second quit from your home screen, from this screen, from your graph. So it doesn't matter where you're at. Hit your stat button, and you have these three options: edit, calculate, or tests, usually used for stats. But what you want to do in this case, you want to edit in some information. Now, if you have stuff there, that's okay. What I'm going to go in, I'm going to clear, and I'm going to go and delete each one of these. Well, see what I'm doing? Delete. And I'm going to go through, and I'm trying to delete it. And if that doesn't work, and it will, I'll show you another way here. So you see me as I'm kind of talking my way through this thing. I'm going through and deleting and hitting enter for each one. Okay. Or the other faster version, you can go up here and say clear, and it just hit enter, and it'll clear out those values. So rewind the video if that went too fast. But really what I want you to do, again, you stat, hit enter, because you want to edit in some stuff. You're already there, so hit enter. And I want you to enter in your x values in one column. 0, 1, 2, 3, 4. And you can watch this on a YouTube video too if you're interested in it, because you will have to do this for the final. Because all I'm going to do is give you a table and say get the equation. Now, for L2, and again, you're going to have to remember so x, if my x's are all here, I'm going to call those x's L1. And my y's, if I call them L2, you just have to have as many outputs as you do inputs. Remember, that's the definition of a function, right? So for every input, there's one output. You can go in here and say times 0, you had 40. At 1, you had, 45. And if I'm going too quick, again, pause the video. You're going to see this in another video coming up, maybe later this week, or maybe not. We'll see. And negative 35. Now make sure you notice when you put in negative values, if you hit the minus, your calculator will go to an error mode. So always do this little negative sign here. And now I have as many inputs and outputs, or as many inputs as there are outputs. Okay? Again, switching this problem, if I'm just given the table, check this out. Once those are in, hit stat. And instead of editing in information, I want to calculate something. And then there's all these options. Now you can do this for linear regressions too. Remember, y equals mx plus b. In this case, the letters are just different, bx plus a. But for a quadratic regression, go down and find quadratic regression and hit enter. Now, if your calculator looks like this, that's fine. But notice your lists are going to have to be L1, L2, and then you're going to calculate something. Sometimes, we'll see if I can do this. Please bear with me because I'm doing a bunch of different things at the same time. If your calculator does not pull that up and you have an old 83 or an old 84, you'll have what's said to be, it'll look like this. It'll say quadratic regression. And what you have to do is go in and find L1 and L2 and put a comma here. So, and then after you do this, you'll have quadratic regression, L1, comma L2, then you hit enter. And your L1 will be here and your L2 will be here. Got it? Now, no matter what, once I hit this enter button to calculate it on my calculator, you'll get the same answer. But again, that's just a different way. If your calculator is set up like this, you're all set. Follow what I'm doing. If you don't have anything and it's just blank, you'll have quadratic regression. You need to find your L1 and your L2 there. And then once you just have this portion, you're going to hit enter, just like I'm going to hit enter to calculate that thing. Rewind that if that was too quick. Okay, so here we go. Hit enter. So if I can take my calculator and hit enter. And now I'm given an equation where you have an A, a B, and a C, and I'll explain that R in a different video. But if I'm going to rewrite this function, now A is 5, so that goes in this spot here. B is 10, so that goes in that spot there. And this equation is the same equation minus 5x, except that they use t. Calculator always uses x. Minus 5x squared plus 10x plus 40. And hopefully that's what this equation was here. Notice your function here, minus 5t squared plus 10t plus 40. So doing that, again, the bonus part of this video was finding a quadratic regression. And you could find a linear regression, which is this an equation of a line. This one's quadratic because the highest degree is this 2 here. You can do exponential and logarithmic and all sorts of things. So all that's coming. I hope that helps. I'll stop there, and good job. Take it easy, and I'll see you soon.